What is going on, guys? Welcome back. In this video today we're going to take a look at a mind-blowingly fast Python package and project manager called UV. This is an all-in-one tool that has the potential to replace multiple tools like Pip, Poetry, and PyEnv. And in this video today we're going to discuss why you should start using it. If you like this content, let me know by hitting a like button and subscribing, but now let us get right into it. Alright, so we're going to take a look at UV in this video today, which is, as I already mentioned, an extremely fast Python package and project manager, and it's written in Rust by the same people who have also developed Rough, this Python linter, which is very popular and also written in Rust. Maybe I'm going to make a video about this in the future. But today we're going to talk about UV, and UV is extremely fast and it's extremely capable. So you can scroll down here on the GitHub page and you can see they claim they can replace Pip, PipTools, PipX, Poetry, PyEnv, Twine, virtual environment, and more. So you can do a lot of stuff with UV. It's an all-in-one toolkit. And as I mentioned a couple of times already, it's extremely fast. What I want to do in this video today is I want to show you how to use it. And I want to also do a rough speed comparison compared to the other usual approaches. Not all of them. I just want to show you a basic example of creating a virtual environment, installing packages, and then I want to show you how this works with UV, and I want to explore the different commands that we have. So for this, what I'm going to do is I'm going to open up a terminal. I'm going to navigate to my working directory, and in here now I'm going to simulate creating a new project. So let me first of all remove everything that I have here, and then I'm going to simulate just creating a new project, starting from scratch, creating a virtual environment, installing a couple of packages, and so on. What I usually do is I create a directory. Let's call this some project. Then I go into that directory, and then I create a virtual environment. So for example, I could use python 3-m venv.venv. This would create a virtual environment. Then what I would do is I would source the activate function or binary, so bin activate. And now I have my virtual environment. If I run pip3 freeze, we're going to see I have no packages. If I run which python 3, we're going to see that I'm using the virtual environment here. Perfect. And then what I would do is I would start installing dependencies. For example, pip3 install numpy pandas scikit-learn. And then I would run this and I would wait. It uses the cached versions. It installs them, takes some time. If I have to download them, of course I have to download them and wait even more, but you can see the installation in and of itself takes some time. I have to wait for this to finish. There you go, I have it. And then what I would usually do is I would do something like pip3 freeze, and I would then write this into a requirements txt file. I would take a look at it. There you go, you can see all the packages and all the versions that I have here as constraints. And then I would start coding, and maybe I would update or remove or uninstall, install dependencies, whatever. But you saw it took some time, and it's not, the fastest way to do it. And of course, you have other stuff like Poetry. I think I also have a video on this channel about Poetry, which you can check out if you want to. But there are many things that are missing here. Of course, a proper dependency file with a proper TOML file with the dependencies. And also other tooling, but to keep it simple, just installing packages took quite some time here. So let's go back and let's create a new, or actually let's not create a new directory. Let's first of all now install UV. And installing UV is very simple. You can use multiple ways. You can use a curl command, you can use cargo, so the Rust package manager, but you can also just use pip. So you can go ahead and say, first of all, let me deactivate my environment. What you can do is you can say pip or pip3 install UV, and that's it. This installs UV onto your system, and now we can do the same thing as before. We're going to create a new project. Now, instead of creating a new directory manually, what I'm going to do is I'm going to say UV init, and then I'm going to specify a directory name. So let's say new project, for example. This created a new project. Now I can go into that directory, and here I already have a couple of things set up. First of all, I'm using some Python version here, which is displayed. I'm also having a Git repository. Now, you don't have to have this displayed in your command line. This is my Z shell showing all of that. But in general, you have a couple of things set up here. And one of the things is a pyproject.toml file. So here we have the name, version, and so on, and we have a dependency list, which currently is empty. So what we can do now here to add dependencies to the project and also install them right away is I can use the command uv-add. And now see what happens, because maybe you're going to miss it. It is very fast. If I say uv-add numpy, pandas, and scikit-learn, it's done. Done. Period. Everything's installed and everything's there. No waiting, nothing. It's done. And I can show you that this is the case. I can just go to the main py file. I can import numpy. I'm not going to use the alias now, just to show you that I can do the import from scikit-learn. Let's go and import from svm, I don't know, svr or something. Now, how do you run this actually? You don't use Python. What you do is you use uv. So you can either use uv run python and then the file, or you can just directly say uv run main py. And this is going to execute the file. And in this case, it imports everything, and there you go. This installation is extremely quick. And I can do this also with more comprehensive packages. I can say uv-add torch, for example. And of course, it has to download stuff. So if you have to download something, you have to download it. There's still the bottleneck of your internet connection. It cannot just magically teleport the package onto your system. You will always have to do the download. But besides that, the installation, the building, everything is extremely fast. So I have around 30 megabytes per second download rate. So it takes some time, but once we have all the stuff installed or all the stuff downloaded, the installation is super quick. There you go, done. If I do this with an ordinary pip command, it's going to take a very long time. The cool thing also here is it uses global caching. So if I go to a different project, different directory, and I want to also install Torch, it's going to use all the cached wheels and all the cached packages, and I don't have to do it all over again. So that also is very fast. Another thing that I want to show you is right now we just created a new project by saying uv init. We can do uv init -- and then we can specify app, which is the default. So uv init app, and then the directory name creates an application, which is the same thing that we just saw with the main py file and so on. But we can also say uv init -- lib, and then my library, for example. This is going to create a different structure. So if I go to my library here, now I have a source directory, and here I have some other files. So it's a different structure. We're not going to cover that in more detail here, but I just wanted to show you you can create apps and you can create libraries, and you can also create apps within apps or projects within projects. So I can go to my new project here, and it's going to consider the sub-projects that I create here part of this overall mono repo, basically. So if I say uv and then init sub-project or something, then you can see here that sub-project is a member of the workspace from new project here. And you can see that this is the case because we have a single log file for the entire thing. So if I go to my project now, if I go to my sub-project here, I don't have a log file. Even if I add some stuff here, I don't know, uv, let's go to uv-add, I don't know, matplotlib or something. All of this is still handled in the same log file. So if I look for matplotlib here, you can see it uses matplotlib. Also, I'm not sure now where it actually was added. So let's go to the project. Yeah, actually, it's in the sub-project toml file, which is exactly what I wanted. But all this is still handled in the same log file. Now, what is a log file? A log file is a file that manages the exact versions. Now, the PyProject toml file is a specification. It tells us what the dependencies are constraining. So here it says I need a NumPy version that is greater than or equal to 2.2.4. Same for pandas and scikit-learn. It gives us constraints, but it doesn't give us the exact version. It also doesn't freeze the sub-dependencies. Whereas if I look into the log file, I have the actual files that are, or the actual packages that are installed. So if I go to something like pandas, here, of course, I still have the specification. But if I go further, you can see I have pandas 2.2.3, and I have all these sub-dependencies, everything here frozen deterministically, which means that if someone else has the same log file, they can have the exact same setup that I have here. And this brings us to two other commands that are also very important, which is uv lock and uv sync. So if we use uv add and also uv remove, we can do all in one. So if I can say here uv remove pandas, this is going to remove pandas. Done, uninstalled. So it's going to remove it from the pip-project.toml file, it's going to remove it from the log file, and it's also going to uninstall it, all in one. Same for uv add. If I say uv add pandas, everything is happening in one go. However, what I can also do is I can go to my pip-project.toml and manually add a dependency. For example, I can say here, let's go with pillow, and I don't even specify a version here. So if I do that, what I can do is I can say uv lock to take what's in this toml file and add it to the log file. So now this is, actually I'm not sure if anything changed here. Let's add some other package. Let's say TensorFlow, for example. And now if I say uv log, you can see here, oh, okay, this is now interesting because this is also another feature of UV when it comes to the dependency resolving, because that is an NP-complete problem, and here it already tells me this is unsatisfiable because TensorFlow requires a specific NumPy version that has to be below a specific version, so it requires NumPy to be below a specific version, but I'm requiring here in the project NumPy to be above a very recent version, and because of that, that's incompatible. It's not possible. We're not going to do that. It basically tells me here it's impossible. So I can go to my pip-project.toml file. Let's do something else that's maybe not that tricky. Let's go with SQL Alchemy and see what happens when I do uv lock here. Now, this is what I wanted to show you. It added the things here to the log file. If I go now to the log file, and I go and look for SQL Alchemy, you can see all of this was added. A concrete version was added, 2.0.39, but the installation did not happen. The only thing that happened is I took my constraint from the toml file, and with uv lock, I translated that into a concrete setup. So it said, okay, let me look at all the constraints I have, all the packages that need to be installed, all the versions, all the subdependencies. What can I do to make this work? So it tries to solve this NP-complete problem or NP-hard problem of this satisfiability of all these constraints. And what it does is it comes up with a solution. This solution is then written into the concrete version numbers in the log file. And now if I actually want to apply this to my environment, if I want to take whatever the log file says and I want to actually do the installation, I have to say uv sync. And this is going to take that and actually install the packages as defined in the log file. Again, all of this can be done in a single run by saying uv add and uv remove. None of that needs to be done manually. You can of course also say stuff like uv add and then a string, and you can say something like flask, for example, being equal to 2 asterisk. This is also possible. And if you go into the toml file, you can see this is exactly what's happening here. So you don't have to just specify the package. You can also specify the version constraint here. But all of this can happen in one go with add and remove, but you can also do it manually with lock and sync. So this is very convenient here. Another thing that we can do with UV is we can manage different Python versions, so we don't need pyenv anymore. We can say UV Python list, and this is going to give me all the Python versions that are available here. I can also say list only the installed versions, so I can say only -installed, and this shows me only the Python versions that I already have. I can also pin a specific Python version. Right now you can see here I'm using 3.12. If I say UV Python pin 3.10 actually is incompatible. Okay, I need to change that in my project file here because that is of course not correct. If I'm requiring 3.12, I cannot just downgrade to that. So let's go and say UV lock, and let's pin 3.10. Okay, now of course trying to pin 3.10 is a problem if our required version is above 3.12. So what we can do here actually is again UV Python list, not just the installed versions. We can see, okay, there are other versions here as well. And what I can do now is I can say UV Python install 3.13. That is going to install a Python version onto my system. And now I can say UV pin or UV Python pin 3.13, and now I'm using 3.13 in my project. So you cannot see that here right now, but now you can see it. There you go. So this is now using Python 3.13. I can also see that that's the case by saying uv run Python. This is going to, actually, what is it doing right now? It's installing the packages. Oh yeah, because of course I have a new Python version, so I need to run all the dependencies again. I need to install everything again from scratch because now we have a new environment. So it downloads everything for the respective version. Then it's going to install it again, and then I'm going to be able to open the interactive Python shell. And then you're going to see that the version number there is 3.13. There you go, Python 3.13, and I can run exit here, which is a feature of Python 3.13. Great. So that is also something we can do. Another thing that we can do here is we can do uv publish, which I'm not going to explain in more detail now, because what this command basically does is it allows us to upload our packages to an index. So here you can see uv publish. I can specify username, password, token, and then I can just publish a package, which is probably way better than using setup py and everything, setup tools and so on. Maybe I'm going to make a video about this, a modern way to release your own Python package, because I do have an older version on my channel. This would be something interesting to look at, but we're not going to do this now. Another thing that's quite convenient here for those of you who want to use UV, but you don't want to get used to this new syntax, is you can use the pip interface. So you can use UV pip, which is actually using UV still, but you can use pip syntax. So I can say pip install, so UV pip install, and then, I don't know, let's go with fast API, for example. This is basically the same as doing UV add fast API. But I can also do it in a different way. I can say pip install fast API -- upgrade, which is going to allow me to use UV exactly the same as before. So, or as pip before. So that's quite convenient for those of you who don't want to get used to a new syntax. I can also do uv pip uninstall fast API, no problem. There you go. All right, what else do we have? We have tooling. The tools are also quite useful. You can install tools. The basic idea is you have certain packages that come with executable CLI tools. For example, Jupyter with Jupyter Notebook, or Rough also with Rough in the command line. Also Scapy, or stuff like, I don't know, what else do we have? Packages that allow you to use a command line interface essentially. And what you can do here is you can say uv tool, and you can then install tools, or you can just run certain tools. For example, we can say uv tool run Jupyter, and that is going to install Jupyter. So as you saw here, it installed the packages very quickly, done. But I can now say uv tool run Jupyter Lab, for example. This is going to just open up Jupyter Lab in the browser. So now this is on my second screen. Let me move that here. There you go. We have Jupyter Lab opened up here. And there's also a shorter command that we can run. We can just say uvx. Uvx is basically an alias for the uv tool command. And if I say, I'm not sure if I have to say uvx run or if I just say uvx Jupyter Lab. Yeah, uvx Jupyter Lab runs Jupyter Lab. And the same thing can be done with Rough. If I say uvx Rough, it's going to install Rough and use it. Installed one package in 2 milliseconds. You can see you don't even realize that something is being installed. I can say uvx run Scapy. There you go. Done. Super, super fast. And I think speed is really mind-blowing, but also having everything in one place is super, super beneficial. So I wouldn't say that I'm a pro on UV. There's probably stuff about UV that I did not cover, that I did not take into account here, that I did not talk about extensively. So I would recommend you go to UV's GitHub repository, you go to the documentation, you read through the different features, and maybe you also read through respective forums, you watch other videos that tell you maybe why it's not a perfect tool. But for me, this is super, super impressive because it's so damn fast and it's so comprehensive. You have everything in one place. You have this universal log file that you can use. You have proper dependency management, and you have extremely fast installation, syncing, and removal of packages. So I would definitely recommend that you check out UV. So that's it for today's video. I hope you enjoyed it and hope you learned something. If so, let me know by hitting the like button and leaving a comment in the comment section down below. Let me know if you want to see more content about UV or other tools, other Rust-based tools, maybe Rough or something like that. Let me know in the comment section down below. And of course, if you want to support the channel, hit the like button and subscribe to not miss a single future video for free. Other than that, thank you much for watching. See you in the next video, and bye.